So the next example will have one of those, one of the last three rather exotic cases. So let's see where I have it. I think I have it here. Here's the example. Let's evaluate the limit is x approaches 0 from the positive side. So 0 plus 1 plus sine x to the power of cotangent x. So let's see, what's the issue with what happened when x goes to 0? Well, 1 plus 0 is 1, so the base is 1, but cotangent of 0, remember the cotangent is the cosine divided by the sine. So you have cosine of 0 is 1, that's okay, but sine of 0 is 0, so we end up having 1 to the power of infinity. So if we're looking directly at the limit, we end up having 1 raised to the power of infinity like so. So we have an issue here. We don't know. This is indeterminate. So what should we do now? Well, we need to define something that will help us to deal with this expression. Here's the hint. Every time you see an exponent, think about using the logarithm to simplify the exponent. So, for instance, if I'll define the y, y equals 1 plus sine x raised to the power of cotangent x, right? And then the natural log of y will be the natural log of this expression. Well, it's cotangent x times the natural log of 1 plus sine x. And then perhaps I can work with this expression. So now I'll take the limit from both sides, and say the limit is x approaches 0 plus of the natural log of y. This would be on the left, supposed to equal the limit when x approaches 0 plus of the whatever I have on the right side, which is the cotangent times 1 plus, natural log of 1 plus sine x, like so. Now, remember, in order to be able to use L'Hopital, I need a rational function. I need to have 0 over 0 or infinity over infinity. So I need to write whatever expression I have here in the bracket. I want to come up with the rational function. Well, one thing I can do is to realize that the cotangent is 1 over the tangent and use this fact. So on the right side now, we have the limit as x approaches 0 plus, and we have the natural log of 1 plus sine x divided by, instead of the cotangent, the tangent, like so. And now let's see, are we qualified for L'Hopital here or not? Okay, we have, on top we have natural log of 1, well, that will be 0. At the bottom, tangent of 0 is also 0. So this is good. We are qualified for L'Hopital. Okay? So this is 0 over 0, and therefore we can apply L'Hopital. So I'll write here, and the limit, and now we'll take the respective derivatives. So the derivative on top, okay, natural log of anything will be 1 over whatever the argument of the natural log. In this case, it will be 1 over 1 plus sine x on top, but then I need to take the derivative of the sine x. So I need to multiply it by cosine x. So I need to take the derivative of 1 plus sine x. This is the same as, this is still cosine x. The derivative of the tangent is the secant squared. So let's see where we stand with this one. I'll take your suggestions here. What do you say about the secant? The secant is 1 over cosine. So the denominator is 1 over cosine squared. So I have cosine squared multiplying the numerator. Okay? If you don't see it, let's do it slowly. The numerator will be this one. That's not a problem. The denominator, however, is 1 over cosine squared. Okay? And now, remember how they taught you in middle school, I believe? When you divide a fraction by another fraction, you multiply by the reciprocal, and you end up having cosine cubed. Now we can apply direct substitution because cosine of 0 is 1, and 1 plus sine of 0 is 1. So this will be 1 over 1, or simply 1. Okay. Are we done? Well, the answer is not yet. Because on the left side, I don't have y. I don't have the limit of 1 plus sine x. I have the limit of the natural log of y, right? So we need to do something with the left side. So here we go. We're going to say that what we have at this point is the limit as x approaches 0 plus of the natural log of y, like so, equals 1. What do we get out of here? First of all, what do we know about y in this case? Well, natural log of y equals 1 means that e to the power of 1 equals y. So this tells me that the limit of y as x approaches 0 plus is e to the 1. And therefore, y by itself, since this is a constant, then we get y equals e. And we can conclude, let's see, I hope I have enough room here, that the limit as x approaches 0 plus of the function that we started with, 1 plus sine x raised to the power of cotangent x, like so, equals e. Let's see if I can squeeze it at the bottom of the page. Like so.